Okay, so the problem was the matrix system was entirely messed up. I'm not sure what that tutorial teaches, but it's definitely not what I was going for, so I did a bunch of research. And yeah, so now it renders in the center of the screen. So it stays the same size though. But what I would need to do is rebuild, or I would need to scale up the HUD system. What I'm probably going to do is scale the HUD system based on the width and the height. I'm not sure exactly, but this is a pretty major breakthrough. And after this, I can implement a basic system for utilizing this and all that good stuff. So everything was flipped basically. It was true. It was pretty interesting. So if we turn off the HUD scalar, let me do new vector 3F000. This should it's probably going to be facing towards the camera because I fixed it. Yes, okay. That is definitely something. But now I can actually properly render stuff, basically. So this is pretty nifty. So we'll see how this goes. I was wondering why the tutorial wasn't working properly, and basically this was set on Ortho 2D, and if you have Ortho 2D enabled, bad things happen. Like really bad things happen. Like this. There's nothing there. But now, if I just redo the ortholinear, with the ortholinear, basically it will render screen locations versus the two-dimensional stuff. So now it's a fully three-dimensional HUD system without having actual 3D implementations of FOV and whatnot. So if I just undo what I did before, I'm going to go back, and of course it needs to be scaled up a bit. You can see there's no FOV no matter where the player is on the screen, which is extremely useful. So this means I can now utilize this in inventory systems, and I can have direct screen access of where everything is. So this is very cool, actually. So this will allow me to do a lot of math to implement inventory systems, so we'll see how that goes. Oh man, this was quite interesting, but I'm glad it's in now, because now we can do some cool stuff with it. So, very nifty. Very nifty. So I'm going to go implement the rest of this, try to make it work properly, because you can see that no matter what I do, it is centered on the screen, and it is actually centered. The player's head is the center, and I built it downwards, which was probably a really bad idea. But if I just take the height, the total height, and I adjust everything upwards, I can get the center of where the actual player is. But the reason why I implemented it like this is because the actual systems for the rotation of the block boxes is implemented strangely, because it's built for the world blocks and not for the inventory system. Let me go to the HUD on tick on step. Okay, here we go. Player rotation x plus equals 0.1f. So this should yield some interesting results. Also, I need to do a loop vectorization for that. Or not a loop vectorization, but a limiter. You can see it's very interesting. And if we want to get even more interesting, we can just duplicate this and then go over here, like that. Now this thing's going to be all over the place. Whoa! Amazing. You can see I messed up the foot block box a little bit, but you know. It's a prototype. And this just looks ridiculous. So I can create a basic bone system without actually having a bone system to work from. Basically, I can do a bone registration to part of the model, and I can have the model built up into different meshes, and then just kind of go from there. We'll see how that goes. But yeah, this looks kind of ridiculous. But it is very cool that it is no longer FOV oriented. So if I actually move this to the right, let's move it like 100 pixels to the right, because it is in pixels. Let's move him really far to the right. We'll just say like 500 pixels. I'm not sure if he's going to be on the screen. So he's like kind of off the screen. But you can see, because it's ortholinear, if I turn off the that, and I do another vector 3F of 0 rotation, then we're gonna have some interesting results. And you can see that he no longer has FOV, which is fantastic. This is exactly what I wanted to do, because what this allows me to let people do with relative ease, actually, is be able to implement 3D HUD elements, and no matter where they are on the HUD, there is no FOV oriented unless they trigger it. I'm not sure how I'm going to implement the triggering of that. I don't know how I would do that, but for now they can do 3D elements on the HUD, and they don't have to worry about where it's going to go on the HUD, because it is just there, you know. It's not going to be twisted by the FOV anymore. So that's cool. So this, now that I figured this system out, and don't get me wrong, this system was horrendous to figure out. I think it's taken me a week now to figure out ortholinear, coming from FOV perspective programming. But this allows me to do a whole bunch of new stuff, so this is very cool. Let's see, what else did I want to do? Oh yeah, so I wanted to do a rapid FOV, no, not FOV, a rapid development of particles with kind of like how Minetest and Minecraft does their particles, but I want to use simpler point-based systems so that that way I don't have to worry about the system being too complicated and being too heavy, because I noticed that Minetest does a full collision box for the systems that they utilize to render particles, and I remember one of the core devs was saying that the reason why it was lagging was because it was getting sent to the GPU from the CPU, but what I've researched from the source code is that it is a full collision box. So that is definitely not good. It needs to just be a point base, because it's just a particle. No one's gonna give a shit that a particle's clipping through part of the terrain or clipping into stuff, because it's a particle system. Now, if flares are starting to clip into the terrain, there's a serious problem. But a particle is just a particle. It's a visual effect, and I can write a particle shader, which can quickly, basically face towards the camera no matter what. And then what I can do is I can create a system for straight up particles like fire and like different effects like smoke that are straight up, stuff like that. And it can just take the position in 3 dimensions and automatically render it out with the texture. And you don't have to worry about readjusting how the particle is facing. The actual OpenGL element of the shader, the vertex shader, will transition the information of the 3D position into the position on screen. So I think that's going to work very well. It's going to be very complex to implement. I'm going to have to research some OpenGL vertex code, but I think it should come out pretty good, honestly. We'll see, we'll see. I should be able to just have a default 4-dimensional matrix float of just a default particle thing and just render it out. Kind of like I'm doing in Ortholinear, but instead rendering it out in 3D, but it's going to be very complicated, so we'll see how that goes. Yeah, I think that's all I got for now, guys. Just this guy up here on the screen. And yeah, I'll see you in the next video, and peace out.